The headline claims an AI named Mythos found a critical vulnerability in the curl library, and you clicked because you want to know if this changes everything. The reality is far more complex and actually more urgent than a simple headline suggests. This story is not about a new bug in a coding library, but about a fundamental shift in how we must trust the AI tools embedded in our own supply chains. By the end of this explanation, you will understand why the discovery of a specific flaw in curl version 8.4.0 reveals a dangerous blind spot in our reliance on automated security agents. To understand the stakes, we must first look at the actual event. In October of 2023, a critical heap overflow was identified in curl 8.4.0. This was designated as CVE 2023-38545. The severity was rated as high, and it affected how the library handled HTTPS connections. A Hacker News thread later circulated discussing an AI tool called Mythos that supposedly discovered this flaw. The narrative quickly formed that artificial intelligence had outperformed human auditors. However, the evidence suggests a different reality. The vulnerability existed for years before any AI tool was involved. It was a long-standing code flaw that human engineers had identified, not an emergent insight from a machine. Here's the thing that makes this situation so critical. The real problem is not that an AI found a bug. The problem is that the industry is now assuming that AI can replace the rigorous, human-led verification that has always been the backbone of software security. We are seeing CI and CD environments, like GitHub Actions and Azure DevOps, rushing to patch runner images because of this specific flaw. The urgency highlights the fragility of embedded dependencies. If a single library update can break the trust chain, then the entire foundation of our automated deployment pipelines is at risk. Consider the specific nature of this vulnerability. It involved a heap overflow where the system failed to properly validate input during a specific HTTPS operation. This is a classic memory safety issue that has plagued software for decades, yet the discussion around it has shifted toward the capabilities of AI. A user named Piru on GitHub argued that a related issue, CVE 2023-2001, was never a true vulnerability, but rather a misconfiguration or a misinterpretation of the specification. This debate highlights a new failure mode where automated agents might hallucinate or over-index on edge cases. When an AI flags a configuration error as a critical security flaw, it forces engineers to build human-in-the-loop verification layers specifically for AI-generated findings. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This brings us to the core of the shift in trust. The narrative suggests that because an AI found this issue, we can now trust AI to secure our systems. But the data tells a different story. The Mythos agent and even smaller local models were able to replicate the discovery capabilities of specialized security agents. This means vulnerability scanning is becoming a commodity capability. It is no longer a unique value proposition for enterprise AI roadmaps. If a small, untrained model can find the same flaws as a massive, centralized agent, then the security advantage of relying on a single vendor's AI is diminishing. Now, consider the implications for the future. The discovery of a flaw that has existed for years by an AI that was never explicitly trained on that specific codebase demonstrates that we cannot assume the model is a passive tool. We must verify its emergent reasoning patterns against the specific threat model of the host system. The fact that local, small-scale large language models independently found the same curl vulnerabilities as the larger Mythos agent indicates that the security advantage of massive, centralized AI models is diminishing. This forces a reevaluation of whether to trust a single vendor's AI or a distributed network of smaller, auditable agents for supply chain integrity. The incomplete fix and the subsequent debate over whether the issue was a true vulnerability or a spec interpretation highlight a new failure mode. AI agents may hallucinate or over-index on edge cases, requiring engineers to build human-in-the-loops verification layers specifically for AI-generated security findings before they impact production trust boundaries. This is not just about patching a library. It is about recognizing that the black box of AI tools we rely on for work or learning might be fundamentally unsafe due to external vulnerabilities we cannot see. We are moving from a world where we trust the code to a world where we must trust the reasoning process of the tool itself. The knowledge gap remains significant. Without a comparative benchmark showing AI discovery rates versus traditional methods for this specific CVE, the claim of a fundamental trust shift remains speculative rather than evidence-based. We are operating on the assumption that AI is superior because it found a bug, but we have no data to prove it found it faster or more accurately than a human auditor. The urgency to patch runner images in environments like GitHub Actions highlights the fragility of embedded dependencies. The real-world impact is evident, but the cause is often misunderstood. This leads to the most valuable insight of all. The Mythos case exposes a critical blind spot in AI supply chains. Small, untrained models can replicate the discovery capabilities of specialized security agents. This means that vulnerability scanning is becoming a commodity capability rather than a unique value proposition for enterprise AI roadmaps. We are seeing a shift where the security advantage of massive, centralized AI models is diminishing. The trust we place in these tools must shift from assuming the model is a passive tool to verifying its emergent reasoning patterns against the specific threat model of the host system. In conclusion, the Mythos story is a warning. It is not a celebration of AI capability. It is a stark reminder that as we embed more intelligence into our infrastructure, we must also embed more skepticism. The vulnerability in curl 8.4.0 was a human problem solved by human standards, yet the narrative has been co-opted to suggest an AI revolution. The real revolution is the realization that we can no longer trust the black box. We must verify the reasoning, audit the models, and recognize that a small, untrained model can find the same flaws as a massive agent. The future of security depends on this shift in trust. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.